So what's going on, guys? DIY Dan here again, and in this video I'm actually going to be diagnosing and repairing some of the inflatable / blow-ups that I have for my Christmas decorations. Now some of these things are well over 10 years old and the motors were just getting a little worn out, had some burnout bulbs, so I'm going to go over diagnosing and repairing these things step by step so it can help you diagnose and repair some of your blow-ups. So let's get to it. So everything I got to repair these blow-ups was off of Amazon, which has made it a heck of a lot easier to repair these blow-ups versus possibly scrapping them and just going and getting a new one. And depending on what you paid for your blow-ups, it might not even be very cost effective to try and fix them. In my case, I had one that had a little bit of a sentimental value to it because it was one of the first blow-ups that my daughters picked out when we really started going nuts with our Christmas decorations. That was probably 10 to 12 years ago, and I think we bought it on clearance for less than 20 bucks. And I did end up paying about $25 to replace the blower fan and add new LED lights to that blow up. But it was worth it to my wife and I because of that sentimental value, and you'll just have to judge that for yourself with the blow ups and inflatables that you might have that need fixed. So because there's a lot of information in this video, here's a little breakdown of what takes place and at what time, so if you don't need to watch something, you can bypass what you don't need to see. So real quick, I'm going to go over what I found on Amazon in order to replace and repair these blow ups. So I still have blow-ups that still use the incandescent light bulbs. So these were a C7 bulb, and I got the LED replacement. I also got them nice and bright so they would light these blow-ups a lot better than what they were before. And here is a couple of the blower fans that I got. This is that one that I got to fix the Hello Kitty blow-up, which had that sentimental value. It did cost me about $25. One thing I do recommend is getting blower fans that are rated for a bigger blow up than what you're actually using it for. A good example is that Hello Kitty. She's about 3 foot tall, and I believe that blower fan was rated for 4 to 6 foot blow ups. So this blow up has 10 years of wear and tear on it, so obviously it's not going to hold air as tightly as it did when it was brand new, and that's another reason I say go with one that's rated for a bigger blow up than what you're actually using it for. Now there were cheaper blowers available, but they didn't have as many LEDs, or they were for smaller blow ups. If you end up with a bad capacitor for one of the motors, they also sell those on Amazon, and they do carry the converters or rectifiers separate as well. All things I'm going to go over in this video. One thing above anything else is make sure there's also free returns in case it doesn't work for whatever reason. This blower motor right here, I paid almost $70 for. I was trying to fix a 16-foot blow-up Santa Claus airplane, and it didn't put out nearly enough air volume to supply that blow up, so I did end up returning it the next day after getting it. So these blow ups usually have a zipper compartment to access the motor, and then on these bigger ones there's a couple straps that are attached to the base of the motor stand that you just have to unclip in order to get it open enough to access the motor. Now I actually kind of did something stupid here. I had this thing plugged in the whole time while I was doing this. So not being able to see what I was doing and reaching in there, if there was a cut wire and that's why the motor wasn't working, I could have got electrocuted here. So when you're disassembling it, make sure it's unplugged. Then you can access the motor, get everything where you can see it, then plug it back in if you want to check further. So once I saw there was nothing wrong with the wiring, I did disassemble the motor so I could check it further. So there's a handful of screws that hold a little plastic ring to the stand itself. This is what seals the blow up to the stand. So I removed those. Now what I should have done is remove the handful of screws that attach the motor itself to the base before removing this ring, but since it was my first time doing this, I hadn't figured that out yet. So that's why I'm struggling getting the material off or from around the motor. If I would have removed those screws from the motor first, that would have came right off. So now I'm removing those couple of screws that hold the motor to the base, which is what I should have done before removing the ring. Plus, on another blow-up I had, you could not even access all the screws to get the ring off without removing the motor to begin with. I removed the screws to the cover over the squirrel cage, which is the fan of the motor. Then I went ahead and plugged it in one more time, and then using a screwdriver, I tried to turn the squirrel cage to see if it would start turning on its own. So most larger motors have a capacitor that kind of gives the motor a jump start to get going, and by using that screwdriver to kind of turn the motor over a little bit, if it would have started going, that would have been a good sign that the capacitor has gone bad. So since that didn't tell me anything, I decided to remove the couple of screws that held the cover where the wires go into the motor itself. This allows me to access the capacitor and see if there's any bad connections in there. Once again, for safety reasons, make sure you unplug it before doing any disassembly. Once that cover was off, I was able to look for any loose connections or wires that had come out of their connection points and didn't really see anything. It also allowed me access to the capacitor. Now be careful when lifting this capacitor out. Make sure you don't touch any bare wires because that could light you up like a Christmas tree. So the whole purpose of a capacitor in an AC motor like this is to jumpstart the motor. So they hold a reservoir or residual amount of electrical charge to them that has to be discharged in order to make them safe to touch. Using a pair of dikes with rubber handled, I carefully cut each wire while making sure not to touch any bare wires. Then in order to discharge this capacitor, all you have to do is take a wire and touch either the wire or the bare metal of the spades on the capacitor to each other, and that will discharge that capacitor. Then I grabbed my multimeter and set it to ohms and put one lead on each of the spades going to that capacitor. You should have an open or an OFL on your meter. If you have 0 amounts of resistance, then that capacitor has gone bad. Now, being as though I did still have an open on this capacitor, that means it was still good, which I kind of suspected that anyways. So when testing that capacitor, it might start out with a quick closed circuit and then it should rise to infinity or an open circuit. If that's the case and that's what it does, that means the capacitor is good. If you get a closed circuit reading, basically 0 ohms of resistance, then it is bad. If you end up needing a capacitor, the part number should be on it so you can look it up. So for this little AC capacitor, it really doesn't matter which way you hook the wires up, but I always find it a good practice to put it in the same manner that you would as you took it off. So in this case, I would put the part numbers or the labels side by side and hook those wires blue on the left and black on the right. So if you're having any doubts of what I explained there, make sure you look into it further before trying to check that capacitor, because once again, those do store a residual amount of electricity and can shock the shit out of you. So that led me to the fact that my motor was bad, and it just so happens that I had an older Blowup that just no longer would inflate all the way, which had a big motor that was pretty similar to the one in this Rover Blowup. So I decided to switch it out. Now both of these have lights in them obviously, but the plane had a lot more lights and I just figured it was going to be a hassle to try and redo all the lights. So I cut the 2 wires going to the lights in each one of the Blowups, and then I'm just going to butt connect those back together. I unzipped the bag around the motor and then went ahead and plugged it in one more time since I hadn't used this Blowup in a couple of years, and made sure it was working, which it was. And then I went ahead and removed it in the same manner that I discussed with removing the one from the Rover Blowup. I did end up using a screwdriver to spread apart the clips that held the Blowup to the base, and that was a lot easier than trying to do it by hand. On this Blowup, I also removed the blower motor from the base before removing the plastic ring, because some of the screws for that ring were directly under the fan and I could not get to them. After that, I removed all the screws that held the plastic ring that seals the Blowup to the base off, went ahead and cut the wires that were going to the lights in that Blowup, then carefully fed the material from the Blowup through the ring and up and around the blower motor to remove it. I took the opening of the Rover Blowup and carefully fed it around the new blower motor that I was using. Now this one did seem to be a little bigger and it was a very tight fit getting this material safely over that motor without ripping it further, but I was able to get it. Then I went ahead and secured that plastic ring to seal that material to the base of the Blowup and tightened all the screws down. So now I'm just going to butt connect back the wires for the lights. When doing this with real small wires like this, I like to strip back the insulation twice as far as you normally would and fold that wire back over on itself. The reason I do this is it actually adds strength to that wire crimp, because you've actually got twice the amount of wire that you're crimping down onto. With small wires like this, I've actually sheared the wire as I'm crimping it down on itself. And by having it twice as thick, it just makes it that much stronger when you're crimping down onto it. The other thing I recommend is getting a good set of crimpers. You'll notice the ones I'm using, how wide they are, and it just gives more surface area for you to crimp down onto and makes it less likely to shear that wire and give you a nice strong crimp. Now because these are regular AC lights, it doesn't matter which wire goes where, so you don't really have to worry about that. If they were DC LED lights, then there is a direction to the wire, and I will show you that later in this video. Now because this is going to be outdoors in the elements and possibly getting wet, I am using bare crimp connectors, and then I'm putting heat shrink over them to protect them from water. I do a lot of this stuff around the house, so that's why I have these special crimpers and the bare wire connectors and a lot of heat shrink. So you just got to use what you got. One thing you do want to do is after crimping your connections, give them a little tug to make sure they don't pull out of the crimp connector, because that would really suck to go through all this work and then the first time you go to use it, the connection comes loose and then you got to redo that and take it back apart. So I use my heat gun to shrink this heat shrink down around the wires. However, a house lighter will work just as good for this application. Once connecting those wires, all that was left to do was go ahead and anchor the motor back to the base of the blow-up. When anchoring the blower motor to the base, I would try and aim the exhaust or the pressure side of that fan towards a nice open area in the blow-up. So when it's in operating mode, it has the least amount of restriction as possible. Also, when anchoring it in place, make sure you don't have any of the material from the blow-up restricting the suction side of that blower motor, because that will take away its efficiency. So you'll notice as I'm tightening these screws down and lining them up that I'm tucking back any of that extra material. Once I fully secured the motor in place, then I took any of my extra light cord and kind of wrapped it around the motor just to take up the slack on it, before carefully taking the material up and over the blower motor and zipping it back into place. Once I had that zipped up, I went ahead and plugged it in to make sure it was working. One thing I did forget to do was attach the straps back to that base. So right here you can see that I'm struggling to get those straps attached to the stand because it is blown up right now. The other thing to consider is the timing of that stand with the blow up to make sure that those straps are lined up correctly. One thing I did notice when doing this is that I had a couple light bulbs burnt out in the blow up, so I went ahead and repaired those as well. Now a lot of blow-ups you'll have to go through where the motor is and just unzip that. This one had an extra zipper to access the light bulbs that were more in the dog because it was so far away from the motor. So I unzipped that and then just kind of pulled that light bulb back towards the opening. There's usually a plastic cover that you might need a screwdriver to help you leverage the little plastic clips up and off so you can access and unscrew the light bulb. So when the blow-ups are using lights like this, usually there is a plastic cover that protects the light bulb from water. It also keeps the light bulb from getting hot and burning through your blow-up. So here's an example of what one of those clips normally looks like. And all you need to do is take a screwdriver, or you can do it by hand, is kind of wedge this in here like this and leverage it and get the lip of that clip underneath the other one. And you will do that for all four of the clips. So since this blow-up was pretty old, it had some old incandescent lights. So I did decide to go with an LED upgrade, and I got the daylight one so it would light that blow-up nice and bright. So basically I got these off of Amazon, and they were a C7 light bulb that I upgraded to the LED equivalent. The C7 light bulb is pretty common for use with blow-ups like this, and they're also used in a lot of the villages for Christmas decorations as well. So the light bulb that was in Rover's head was easy to see that it was burned out, so there I replaced that one, and then I went ahead and plugged it in, and I was able to see which other ones were burned out, and I just went ahead and left it plugged in while I replaced these final two bulbs that were burned out. So here is the finished product of Rover, guys, after replacing that motor and replacing the light bulbs in it. And now we're going to get into replacing a motor and the LED lights on much smaller blow-ups. So here is a view of the Hello Kitty blow-up that we're going to be messing with next, and you can see how dull she is. And here is a view of after replacing the motor with a new set of LEDs. So on these smaller blow-ups, usually there's just a zip tie that holds this motor in place. So all I'm doing here is go ahead and find the opening and cut that zip tie off. When cutting off the zip tie, you do need to make sure that you don't rip the material of the blow-up. Once you cut that zip tie, you can go ahead and just unfeed it from the blow-up. So there was two reasons I was messing with this Hello Kitty blow-up. The first is she wasn't very bright and needed an upgrade on her lighting. Right here I've got her plugged in, and you can see that the light is lit. It's just very dull, and I wanted to brighten her up. The other reason is the motor did seem a little weak, and I'd have to push her up in order to get her to stand up on her own. So on these smaller blow-ups that use the DC motor and LED lights, usually the lights are just held in by a plastic clip. Now, because this Hello Kitty blow-up is probably over 10 years old, the plastic clip was very brittle, and when I tried to use a pair of pliers to remove it, it just kind of cracked apart. After removing that clip, I was able to unfeed the wire through the hole where the motor was and remove it completely out of the way. I took the new motor and put it up through the zipper compartment. Then I took the new zip tie that is supplied with the motor You'll notice I'm kind of bending the zip tie so it contours around that ring as I push it through. When putting the motor up into place, make sure you time it so the exhaust of the motor is blowing into a nice open area in the blow up and not directly towards one of the walls, so you have the least amount of restriction as possible when it's starting up. So one mistake I did do when replacing this motor is I forgot to run the power cord through that zip tied area, and instead I ended up having to run it through the zipper right underneath it. So keep that in mind when you're putting these together. Once I had the motor in place and the exhaust of the motor was pointing in a nice open area of the blow up, then all I had to do was go ahead and pull that zip tie nice and tight. So one common mistake with zip ties is people don't actually pull them down correctly. You'll notice right here that I'm just holding the zip tie with my finger and then pulling it down as tight as I could. So you'll notice how easily I'm sliding that zip tie back and forth on the PVC tube. Then just using one hand, I leveraged the zip tie back on itself and how much tighter that is and how much harder it is to slide it on that PVC. The other common mistake with zip ties is when people cut off the tail of the zip tie, they leave a 1/4 inch sticking out, which is about the worst thing you can do because a zip tie cut is about 10 times worse than a paper cut. So if you can't cut it almost perfectly flush with the clip, I just recommend leaving it on and twisting it to a position where it's not noticeable or won't get in the way. So my other complaint with this blow up was the fact that it wasn't bright enough. So I did get that one that had 5 LEDs instead of just one. So right here, I'm feeding the lights into position. So I just used a pointed object like an ice pick, or in this case, I used a thermometer to poke a hole in the material. Then the LED light will push in through that material, and then there's just a little clip that you push over the outside of the material and snap it in position. I did that for all 5 of these LED lights in various positions in the Hello Kitty blow up. Then right here, since I forgot to run that power cord through the zip tie area, I did have to run it out the zipper of the blow up. Now I'm going to plug it in and show you the end result, and as you can see, she's a lot brighter than what she was at the beginning of this thing. So we did accomplish one of the 2 things I was trying to. She is a lot brighter, so you'll be able to see her a lot better. Unfortunately, the motors were about the same strength as far as the fan goes, so I might still have to push her up on the wall. But that has a lot to do with the fact that I don't use the extra support strings to help pull her up into position because she is up on top of a brick wall. So I guess that is what it is. Now I'm taking that blower that I took out of the Hello Kitty and replacing the one that was going bad in this Noel blow up.
Okay, so right here we're going to plug this one in. You can see it's kind of hesitating to go. It's moving very slowly, not really airing up.
So if you have something similar to this happening with one of your blowups, one thing you can try is swapping out the converter or rectifier between 2 of your blowups and see if it switches the problem to the other blowup. In this case, I had done that and it did not make a difference, so the motor was going bad. So the only difference in swapping out this motor between what I showed you in the Hello Kitty blowup is the fact that I was reusing the lights in this Noel blowup instead of using the lights that were in the motor that I'm putting in. Now, being as though this is using LED lights, which are DC current and do have a direction with the wires and they have to go a certain way versus alternating current, which it doesn't really matter. The way you can identify this is usually there will be a marking on the wires. You'll see that this wire is completely white and the other wire is white with gray stripes on it. So you just need to make sure when you butt connect these back together that you line those up appropriately, because if you don't, your lights will not work because there is a diode in LED lights that prevents the current from going the wrong direction. Besides that, I'm not going to go over the electrical connections on this because I did that in the Rover blow up earlier in this video. Everything else is identical to what I showed you in the Hello Kitty blow up. The only thing I did do differently is I did remember to run the power cord out through the same hole as the motor instead of running it through the zipper and pulling it tight. So one other thing I do to my blow ups to prevent me from possibly damaging one in the future is when I get them, I extend the straps that are close to the blow up. So when hammering in the stakes, I don't accidentally rip one of those off because I had that happen to me once. So all I did here was tie a knot in a rope and then loop it through back to itself. That extends those straps farther away from the blow up. So when using a hammer and pounding in the stakes, I'm not close enough to the blow up where I could possibly hit it and damage it. Hopefully you guys enjoyed this video and it gave you some good information. If so, make sure you hit that like button and subscribe to my channel if you haven't already. I'd really appreciate it. The whole concept of my channel is to give you guys the most information in the least amount of time as possible so I don't waste your time. And I hope to see you next time. Have a good one. Later.